These series of lectures in this group are taken from 1201 bonding lectures. And so what I've done is I've condensed them down so they're focused on the material that you need to know for organic. So this is going to go through some of the things that you probably should have learned in general chemistry. The first thing we're going to do is go into basic bonding ideas. And the first thing that you need to know is about valence bond theory. This is the simplest of all the bond theories, and all it says is that valence orbitals overlap and share electrons, or they give up their electrons and take electrons to form charged species, which then are attracted to each other. So there's two different types of bonds that we're going to see in here. The compounds that we're going to look at all are going to be made of representative elements with an occasional transition element in there. For the most part, the representative elements are going to react in a way that bring them to an S2P6 configuration. So they either gain or lose electrons to become S2P6. Hydrogen, of course, will become S2. Or they will overlap in a way that gives them S2P6 configuration, or again, S2 configuration. The ionic bonds are always going to be in compounds that are metals with nonmetals. Now, in organic, you're going to have a big nonmetal compound, a carbon compound, an organic molecule. And a carbon in there will have sometimes a bond to something like lithium or sodium. That bond from carbon to lithium, or carbon to sodium, or carbon to magnesium, that will be an ionic bond. Whenever there's a bond between a metal and a nonmetal, it is ionic. And the reason is because there's such a great difference in their ionization energy and electron affinity that the metals will easily give up their electrons and non-metals take it. That means the metal always has a positive charge and the non-metal always, this is carbon that we're talking about most of the time, although it can be oxygen or nitrogen in our organic molecules, those always have a negative charge. The characteristics are the electrons are transferred from the metal to the nonmetal. That means the metal has a positive charge, it's a cation, and the nonmetal has a negative charge, it's an anion. And they just stick to each other through the attractiveness of the positive to the negative. Ionic compounds are not molecules, they're crystal lattices. This is not so important in the lecture part of the lab when we get to the lecture part of organic, but when we get to lab, it will be important to understand that ionic compounds are crystal lattices. It helps you understand why they dissolve. Okay. Natural charges that we will see on the metals that we use, sodium, potassium, and lithium, will always have a positive charge, at least in normal chemistry. Sometimes there's superoxides and things where they don't have that, but the way that we will use them, they'll always have a positive 1 charge, and magnesium and calcium also will have a positive 2 charge. The transition metals, we're not going to be so worried about what is their charge. They lose a variety of things. We're just going to notice them in certain reactions and recognize that they're reacting. The halogens, when they are eliminated from an organic compound, will always have a negative 1 charge if they're not bound if they're not in a diatomic molecule. So a halogen that comes off of an organic molecule or is going to react with an organic molecule and it's a single atom will be charged with a negative 1 charge. Sulfur and oxygen we will often see with only 1 bond to carbon or hydrogen, and then they have a negative 1 charge on them if they're an ion. If nitrogen has only 2 bonds to it, it will have 2 non-bonding pairs, and it will have a negative 1 charge. The sulfur and oxygen also, if they have only 1 bond, they will have 3 non-bonding pairs and a -1 charge. Covalent bonding is when you have 2 nonmetals bonding. And what happens, they're so close in their characteristics, one atom cannot take electrons from the other. So what happens is they end up sharing electrons. So their orbitals overlap and then they form a bond. So here's an example. Here's hydrogen with 1 electron and 1 s, overlapping with hydrogen with 1 electron and 1 s. They overlap, and when they do, now the hydrogen on the left and the hydrogen on the right both are experiencing, instead of 1 electron and 1 s, 2 s. And that gives it a 1s2 electron configuration, which is the same as helium, and this gives it greater stability. So they stay bonded together. Basically, what happens is the positive nucleus here and the positive nucleus here have electron density all around these 2 nuclei, and a lot of it right here between the 2 nuclei, and it actually draws them together, and we call it bonding. It's basically the electrons with their negative charge draw the 2 nuclei together so that these 2 electrons can see the 2 positive charges, and the 2 nuclei each can see 2 negative charges, and they find that to be a great drop in energy, so they stay in that configuration, and we call it a bond. Now, what we see with larger atoms is a similar thing. Here is fluorine on the left and right. Each have an s2p6 valence shell. When they collide, they have 2 electrons that can be shared. When they share, each of the atoms then are s2p6, and they have a stable electron configuration. And you can see right here, this is a single bond. And then here are 2 oxygens. They can overlap with these 2, but they also can overlap with another. If they just overlap 1 pair, they're not going to have stability because they're going to be s2p5. So they have to share 2 pairs, and that gives them a double bond, and they both then have s2p6 stability. This gives them a double bond right here. And you can see they have 2 non-bonding pairs on each with a double bond. Nitrogen does a similar thing. It overlaps 1, 2, 3 pairs to give you a triple bond between. Each atom is then s2p6, and they have stability from this configuration. So what are the characteristics? These are going to be atoms with similar ionization energy and electron affinity, which means they're both nonmetals. The overlap of the orbitals allows the electrons to spend time on both atoms, and it's the sharing of electrons that causes the bond to form. Stability comes from a stable s2p6 arrangement, or s2, with the situation with hydrogen.